Hello, welcome to this computer networks topics. Here we are going to talk about RS232, a standard serial communication protocol. Before we get into the encoding, let's just look at the basic fundamentals of communication between two devices. We call this as end device. Two end devices are connected somehow to some signaling and they need to exchange information. Now, there are two ways this communication can happen. One is asynchronous communication, another one is synchronous communication. Now, what is the difference between these two? Asynchronous means the device 1, end device 1, and the end device 2, they do not know when each of them are ready to communicate, and the receiving device also is not aware when this source device, let me call it as a one is source, one is a destination, based on the communication, whether it is happening between source to destination this way, then the communication is from 1 to device 2, it is this is source and this is destination, and if the communication is this way, it's the other way around. So when it is going to start sending, we do not know, and in that case there should be a understanding between these two devices that what is going to be the basic configuration of, okay, let me call it as a configuration of the encoding, or we can call it as encoding of the data which is being sent by the source, and the destination should also be aware of that, and in that case that communication can happen properly because the devices can read the voltage levels at the proper time. Then it can sense whether the device which is sending the data is sending a 0 or a 1. Always remember the binary data is flowing through these devices. So to make it happen, RS232 is one mechanism wherein which is following a asynchronous way of communication. That means it doesn't have a synchronized clock between them. Now, what is synchronization? Synchronous communication, wherein you have a fixed clock coming from one common source. It could be each device. It can be generated by one of the devices, and the clock is available to them, both the devices. Then you can say that on clock edges the communications will be happening. So with respect to that, it can be able to it will be able to sense what is happening on the network. So in synchronous there is no clock, asynchronous there is no clock, and in synchronous communication there is a clock, common clock between them. So there are some problems, difficulties, and between these two, and there are some advantages of having one over the other. But let us not go into the details of them. Let us spend some time on what is RS232. Now, before we even communicate, there is a DTE, which is a computer or data terminal equipment, which is converting whatever data it has, a parallel data, because whatever we store in memory is 8-bit bytes of the information which has to be sent over a serial port. Serial port is 1 bit at a time the transfer happens. So there is a parallel to serial conversion on sending, and then serial to parallel conversion on receiving. Now we are going to follow RS232 way of communication, and there is a modem requirement because this DCE, which is data circuit terminating equipment, converts the parallel data which is coming from the computer into a serial data and sends it over a network. It could be a phone network or it could be a dedicated line connecting two devices. So the conversion, or based on the standard whatever encoding that I'm going to explain, needs to be done by a device because it's all happening in the hardware. It's not maybe programmed through software, but it's generated by hardware and received by the hardware also on the other end. So serial data is flowing over the network, and then it is converting them into parallel while consuming it. While sending, parallel data is converted into serial and sent over the network. Now you know the functionality of DT and DC. DC is required for it to convert the parallel data into serial and then put it on the connection based on the configuration and the standard. Okay, now I'll talk about what is a standard all about. Now let us see in RS232 what are the basic connections need to be there. This is a device 1 and device 2, and then you see that there is a TXD pin on both sides, but they are not connected directly. TXD to TXD you cannot connect it because both are trying to send some data out. we have to make sure that the other end has to be in the receiving mode to get what is being sent by the one device. So TXT is connected to RxD of one device, and the TXT of this device is connected to RxD. And there is a requirement that ground has to be there, because the voltage variations that are happening on the signal should be comparable with the common ground. Otherwise, the devices are on different ground levels, then it will not be able to sense the voltages coming. And if it is not able to sense the voltage levels, then it can't find out whether a 1 is coming or 0 is coming on the line. So that is the purpose of a ground line being there. Now, what is the encoding? This is the basic encoding of RS232 standard, wherein either you have a plus or minus 12 volts or plus or minus 15 volts variation, and the minus voltage is given as a 1 and the positive voltage is given as a 0. Means if the data which is being sent by the device is a binary data, of course, and if it is to send a 0 onto the network, then it should put a positive voltage, and it could be configured as minus 12 volts or minus 15 plus or minus 15 volts based on the particular implementation. Now, what is the gap between this? Please remember, this is the timeline, and whatever you see here is the data which is being sent first, and then what is coming next is the next data. So in time wise, the LSB is always sent first in a byte. Suppose if you are to send a byte of data, the LS bit is sent out first. So if the data which is being sent is LSB, suppose we call this as a first bit, then it will be a value 1, then it will generate a minus 12 volts and then plus 12 volts if it is a 0. So that's how the signals could be. The basic various voltage levels are this. Okay. Now, this is the standard defined by EIA and TIA. That's fine. Now, let us see how do we encode it. This is the most important part of this encoding of RS232. Now, what is this start? Let me see, sorry. Start is the first bit, needs to be there always. Okay, it's 1. It says that it is 1 means that needs to be there. And then the data could be 5 to 9 bits. I can decide to send a 5-bit data or a 6-bit or 7 or 8 or 9 bit. So there is a flexibility in deciding what is the bit of the data you are sending. Normally in computer it is 8-bit, but this RS232 standard is standardized to be able to cater for different bits of data. So it could be one of them. And then the parity. This is either 0 or 1. That means, what does it mean? This 1-bit position can be 0. That means you don't need to have a parity at all. In that case, you are not bothered about parity. Maybe you are confident that the data line is error free, and you don't need to waste 1 bit of time sending the parity information. So it could be 0, or if parity is there, then it can be a 1-bit wide. I will talk about what is the width of the bits, and then the stop bit, what is coming at the end, is either it needs to be there for sure because it's 1 or 2, but you can have it as stop bit as a 1-bit time or 2-bit time. Okay, for the time period of 2-bit. Now I mentioned about time period. What is that? See, suppose we need to have a standard of how long I am going to keep this bit value 1 or a 0, or if the start bit is 1 bit, then how long I am going to keep the start bit at 0 value. Okay, start bit is always 0. Okay, remember, that's why plus 15 is given. Start bit is always 0 and stop bit is always 1. So it could be either 1 bit or 2 bit, but needs to be 1 and start bit needs to be 0. That's why plus 15 is given. Remember that plus voltage is 0 and minus voltage is 1. That is standard. So based on the data, it could be all zeros or all ones or zeros and ones combination. You will change this data portion of the signal either 0 or 1. But if you have need to start with the start bit, it always has to be a 0. Okay, so you will have a positive voltage for a start, and it has to be 1. So you need to have a 1 bit wide of duration for which it is going to be high. And then if you support parity, I'll talk about parity shortly. Then you need to generate a parity bit also based on the data. Now the parity could be odd or even, which I'll talk about shortly. and then stop bit comes. Stop bit has to be either 1 or 2 and needs to be a high, one value of 1, binary value of 1, which means that it has to be minus 15 volts. So in this case, if you see, I will observe this. Start bit is 1 as per the standard. Yes, okay, start bit is 1, and then the data bits are 1 0 1 1 0 1, as well as, and then 0 is also there. So how many bits are there? 1 2 3 4 5 6 7 bits are there. So data bit can be either 5 to 9. So 7 is a valid number of data bits. Then stop bit is decided as only 1 bit wide, so it is 1. After that it is idle, and this is also idle. So if based on this signal, example 1, if you need to mention what is the configuration provided in this communication, then you can say the start bit is 1 is there. Of course it is always there, and then the data bit is chosen as 7 bits, and parity, it doesn't say parity is there. P would have been there if parity is there, so parity is 0, and then stop bit is configured to be a 1 bit wide. Okay, now let me talk about what is this width about. Okay, now this signal, whatever we draw, the width of the signal that we see is some time period, right? Suppose if I say it is 10 milliseconds. Now we should have already told the device 1 and 2 that I am going to send in this speed. Okay, 10 millisecond is I am going to take only 10 milliseconds to send 1 bit of information. Now suppose if I configure it to be, okay, some 0 and 1 is coming, and I say that each bit I am going to take maybe 100 milliseconds. In that case, what is happening? I am going to send each bit, I am going to keep it for 100 milliseconds. That means, which is faster? Every 10 milliseconds sending 1 bit is faster, or every 1 minute, every 100 milliseconds sending 1 bit is faster? Of course, this is faster. So this has to be decided before the communication starts. Why should it be? Because this device is, suppose this data is coming from device 1 to device 2. Device 2 is supposed to look at the line every 10 milliseconds to see whether the value is 0 or 1. And if it is deciding to look into the data, it should not look at the transition period because that's changing. So it should try to look at the data at the middle of the information. That's the reason the start bit and stop bit are coming. Especially start bit is coming to indicate that yes, from idle state I am going to keep this for 1 bit duration, 1 bit of duration. Then the device receiving side will be able to find out how long this is, and then it can find out when it is supposed to sample the next data, which is at the middle of the time period. So to know that, it needs to know the start bit is required because the communication can start anytime. As also, it should also know what is the speed with which it is going to be sending. Okay, 100 millisecond or 10 millisecond or even smaller, so that it can sense the data at frequent interval to find out what is the data coming. So once you have this information, suppose this is a duration, will you be able to check the speed? The speed can be BPS, bits per second, or baud rate. Baud rate is number of bars or bits which are baud rate, which is coming in. So how will you know it is already 10 1 by 10? Suppose you have to give it in how many bits per second. So you have to 1 bit is going to take, suppose 1 bit of data is going to take 10 millisecond of time. Then in 1 second, how many bits I will be able to send, right? So it should be the other way around. Okay, let me write it as this way. Okay, 1 second. In 10 millisecond, I am going to send 1 bit of information. Now in 1 second, how many bits will I be sending? That is the PPI, bits per second, right? So this is what I want to know. What is the speed of this particular thing? Then I need to say 1 by 10 into 10 power minus 3 into 1, which is nothing but 1 by 10 and into 1000, right? So 100 BPS, right? So this is how you find out, or 100 baud rate. What is the baud rate? It is 100 baud rate. So this approximately, if this duration is this, you should be able to find out the bits per second the data is flowing, right? Now let us try to understand the encoding of the data. Now let me make it visible to you, the encoding what we saw at the top. Okay, now suppose I am interested in sending a RS232 signal. Of course, start bit is 1, there is no change in it. Here let me say that I want to say it is 6-bit data. Okay, I'm saying it's configured as 6-bit data, and parity, I'll say that odd parity is chosen, and then stop bit is 1 bit. Okay, now I have not mentioned anything about the duration of how much it is, so you can assume some fixed pattern. Okay, so if baud rate is not mentioned, you can assume some fixed duration and then try it. You know, we don't have to mention what is the width of these pulses. Now, suppose if I had to say this, now this is not enough. I need to say plus or minus 12 volts or 15 volts, which is the particular combination we have taken. Now, this is the timeline, and then let us have voltage line. Okay, 1 second. Now I can actually put it down up. Okay, we have decided that we are going to use this combination of information, right? So okay, let me. So 6-bit data, and we said even odd parity we are going to use, and parity bit is 1 instead of 2-bit. I am choosing 1 bit. Start bit anyway is going to be there, which is 1 bit wide, and plus or minus 12 volts we are choosing as a encoding signal voltage level. Now I have to give you one more thing, right? What is the data I am interested in sending? Because that you cannot generate. You can say odd parity, okay, and then stop bit I have to say 1 bit, because parity is always, if it is there, it is 1 bit. Okay, I am choosing odd parity, and stop bit is 1 or 2, but I have decided to have as a 1. So plus 12 volts, minus 12 volts, and you should also remember that minus 12 volts corresponds to a 0 value, plus 12 volts corresponds to a value of 1. So start bit, I told you that it has to be, start bit has to be a value of 0. Okay, and then stop bit has to be a value of 1. Okay, that has to be, it should be high. So let us say that we are starting from here. Okay, you decide to send the data. Now first is start bit. You have to start with the start bit. Now okay, I have brought it down, so let me assume that this value is what? So minus 12 volt is 1 volt, right? This is start bit. Let me call it as a start. Start is always 0, so it has gone into plus voltage, and now I am starting with the value 1. So I have brought it down, so I am assuming that the data bit I am interested in sending is a 1. Now one more thing you have to remember, always the LS bit comes first. Okay, so suppose if I have a data which is a 6-bit data, I will say 0B binary format, C convention. Let me start with the LS bit as 1, because I gave here. Okay, nothing like so let me have 0 0 0 1 1. Okay, this is the data I'm sending. Now this is a mirror image, so whether you, even if you by mistake you do the other way also, it will look same. But remember to always look at the LS bit and mention what is that value here. Okay, it should, LS bit comes here. Okay, LS bit comes here. So now after this one, what is supposed to be sent? Another 1. So let me call this is the width, right? We have decided that this is the width of each thing. So you can even just put it like this approximately. Now I am not going to measure it with a scale. Approximately equal to 1. Okay, 1 width should be equal, and then decide how I am going to draw this. Now this is 1, so this will extend. Okay, you will not go up and come back. Okay, this is continues to be 1, so it remains 1. Now there are zeros are there, 2 zeros are there, so maybe you can write the binary values here and then decide whether you want to go up or remain the value down or not. So you need to continue there being in 0, and then it is having 2 1s, so you have to come back to this value because minus is 1, and you continue. Now you come here. Now before you continue further, what are you supposed to have? Parity bit you are supposed to have. Let me show the picture so that you can recall. Parity bit is coming here and it is not a 0 bit. That means you are not ignoring parity. You are having a 1 bit. Always is a 1 bit parity, but it could be even or odd, but we have decided that it is going to be odd. Now you have to decide whether the parity bit value has to be a 0 or 1. Now how do you decide? Now you have chosen the odd parity as a convention here. It could be even also. And what does it mean? Along with the data bits, depends on whether it's 6-bit data, 7-bit data, whatever it is, data bit. Along with that, the parity bit is also sitting there. If you count the number of ones, it should be odd. That's what you mean by odd parity. But when you send it, when you look at the data and then odd parity bit, it should be all odd number of ones should be there. It should be odd. Now, how many data bits are there? You don't consider the start bit for considering the parity. So you only look at the data bits. How many ones are there? There are even number of ones are there. Now, what should I send as a parity bit? I should send as a parity bit 1, so that including the parity bit along with the data, parity bit is not sitting here, it is coming behind. Okay, including the parity bit, I will make it 1, so that if you count the number of ones, it will be odd. So it looks that I need to have a 1 generated at this place, okay, parity bit side. Now if I had to generate a 1, the voltage should be minus 12 volts, so I should extend it. Suppose if the data was here 0, you would come down and then say it is 1. Okay, so I am saying parity bit as 1. Okay, my job is done. No, parity bit you have generated. Now you have to generate a stop bit, because then only it will be completed. And stop bit, I said that it is enough if you do 1 bit. So what is the stop bit convention? It should be a value of 1. Okay, it should be a value of 1. So in this case, what will happen is, this is the location of stop bit. Stop bit is 1. Okay, this is stop bit equal to 1, and then idle. It is idle is, you don't have to say 0 or 1, you can just say that idle. So here also idle. Okay, so this is how a signal is drawn. You need to practice considering the parity being even or odd, or it could be no parity, and then number of bits of data could be 6-bit or 5-bit or 9-bit, maximum 5 to 9, and I may decide to send any data. It could be what combination bit patterns can be. It could be any bit pattern. And only thing what you should do is divide the timeline, okay, into equal part and then draw this picture. This is what is expected of this. Okay. So with this, we have come to the end of this discussion. Bye bye.